Hi guys, in this session we'll be learning about k-means algorithms. How do you implement k-means algorithm using R? So k-means is a clustering algorithm. So clustering means, as you know, grouping objects based on the similarity. And this k-means algorithm is one of the very fundamental clustering algorithm. It defines clusters so that the total intra-class variation should be minimum. And what are the algorithmic steps? So here we have, you need to specify the number of clusters which is labeled by k. So this is prerequisite. K value has to be supplied, and this is cleverly decided by the data analyst. And then you need to select k random objects from the data set, and by using these k random objects the initial clusters are formed, and then assign each observation to the closest centroid. So how do you find the closest centroid? That is based on the Euclidean distance between the objects and the centroid value. Then once the observation is assigned to the cluster, you need to update the centroid value. The centroid value is updated after assigning the sample to the cluster. And iteratively minimize the total with sum of square. This measure has to be minimum so that the clusters are formed correctly. So the objective of this is, you need to have the minimum sum of square value. In by default, R uses 10 as a default value for the maximum number of iterations. So these are the algorithmic steps. Next, so how the algorithm works graphically, we can see here. First, you need to input the number of clusters. Then the centroid values are calculated based on the initial assignment of sample, and then the distance is computed. Then no, you need to again update the centroid values. So like this, with minimum distance, the samples are assigned to the nearest cluster. Next, how do you implement this? So we are using the data set here, which is USRS, and it is a predefined data set which comes with R. So you can load, and then you need to scale the data, and you can display the header part of the data. So this we better see this using RStudio. So we can also take help on the data set. So you can search for USRS. When you take a help on USRS, you can see this is the violent crime rates by US states, and these are the fields in the data set. There are totally 50 observations, means 50 samples, and with 4 variables. The cases, the 4 variables are murder, means the number of murder arrests per 100,000, and then assault, urban population, and then rape cases. So these are the 4 variables, and we have 50 observations. Next, we shall load the data set. So to load the we can use the function data of USRS, and then we are scaling the data, scale of USRS, and then we'll see the summary of the data set. If you see that, you can see the data frame has been created. If you double click on this USRS, you can see the data set actually. So these are the data set, and you can see 50 observations are there, 4 variables, and next, we can also see the header part of the data. So we are giving n is equals to 3, means we would like to see first 3 rows. So for the 4 types of cases in the first 3 states. So here it is shown, and there is a package called as Facto Extra. So we would like to install that and use it, and this is used for cluster visualization. So in my case, I'm already having it, so just loading. And if you do not have this package, this is a syntax: install dot packages, then specify the package name, and then I'm just visualizing the cluster. So using the data frame here, and then k-means is the algorithms, and the method used is WSS, which stands for within sum of square, and intercept we would like to add at the point 4 and line type is 2. Means the width of the line. You can see the graph. So this is the graph, and here we are trying to find the optimal number of clusters. So this is the one of the method to know the optimal number of clusters. So by looking at the graph, you can see the optimal number of clusters. So how do you determine that? So you have to observe the line and where it is bending more. So here it has bended more, so that's why we have given intercept is equals to 4. So at intercept 4, the line dashed line appears. So from this graph we can conclude the optimal number of cluster means k is equals to 4. So next I'm building a model here. So setting the seed to 12, and then here is my model. My model name is k means dot result, which is user defined variable, and then k means of df, the number of clusters is 4, n start 1. So when you run this, the model is built. You can see the model has been built, and n start means how many random states should we choose. So I have given them the value as 1, and you can also have the result, print the summary of the model built. So print of km dot results. So this is the summary. In the summary, what are shown? In the summary you can see the clusters, 4 cluster, and then what are their sizes. So the number of samples in first cluster is 20, in the second cluster 6, in the third cluster 16, in the fourth cluster 8. And these are the cluster means. 1 2 3 4 are the cluster labels, and in these 4 variables you can see the cluster means. And here cluster vectors means what are the how the states are assigned to 4 clusters. So you can see the label. For example, Alabama state has been assigned to the cluster number 1, and this Oklahoma state has been assigned to the cluster number 3. Similarly, Virginia has been assigned to the cluster label 3. And like this you can see the assignment of all the states, and you can also see the within sum of square value here, right, which is these. For cluster number 1, this is the value, cluster number 2, cluster number 3, cluster number 4. So for the fourth cluster, the within sum of square value is less, 3.87. And you can also see the available components, this is the parameters of the model, and you can also access these properties individually. For example, km dot result, we just want to see the clusters. So this shows the cluster assignment, how the states are assigned to different clusters. And you can also compute the mean for each cluster. So aggregating USRS is a data set, listing the cluster result dot cluster, and then mean. So this will give the mean of the 4 clusters. So these are the means. We have already shown this through the summary. And then I want to add the label, the cluster number, to the existing data sets. So we are using the function cbind. This is the original data set, and cluster is equals to from this we'll be getting the number, so that is added to the existing data set, and we are displaying the header part of the data. So this is the new column which has been added to the existing data. So from this straightforward you can see what is the state and what is this cluster number. As I mentioned, this is we have already shown above. And then tail part of the cluster results. So last 4 states you can see. Tail means last 4. And if you want to know the cluster size, so this is the dollar size, means which gives the number of samples in each cluster. So 26, 16, 8. And if you want to know the centroid values, so you can see km means result dot centers, which gives the centroid values of 4 clusters. So these are the values. And next we can go for visualizing the clusters. So we can use the function fvisualize cluster, and this is the model and the data frame, and we have 4 clusters, so we are specifying 4 different colors. You can specify any color, and then ellipse type is convex. So there are different types of ellipses. So you can see the Manville, and so convex, and then star plot is true, and then repel to avoid the overplotting. You need to set this parameter as true. So when you run this, you can have a visualization of 4 clusters. So if I zoom it, you can see these are the 4 clusters. Cluster 1, 2, 3, 4. 4 clusters. You can see the labels. Cluster number 1 is this. Next, this is 2. This is 3. This is 4. So convex means the shape is in this manner. So you can see the in dimension 1 on x-axis 62% of samples are there. On y-axis 27.47%. So this is the cluster diagram. And next I'm just changing the ellipse type here. Everything is same, and you can visualize your cluster. So the shape is ellipse. You can see that 4 clusters. The first one is better because here you see some samples are falling outside the shape. So the first type is better one. Next, the other type is ellipse type confidence. So confidence means you can see the shape of the cluster in this manner. So this is the shape. So 4 clusters are there. So we have built a model with 4 clusters, and then you can also build model with k value 3, means 3 clusters. So as we are specifying 3 clusters, so 3 colors are there. So everything is same. So when you do this, you'll be having only 3 clusters, and we can see that in the graph. So here are the 3 clusters. Cluster number 1 is this, 2 is this, 3 is this. In the cluster number 3 there are many samples. Many states are assigned to cluster number 3 only. And you can evaluate these models based on the within sum of square value. But you can see for the third cluster, the value is very higher when you compare with the first 2 clusters. So based on the within sum of square value, you can evaluate these 2 models. So that's it about the clustering. So we have used the algorithm k-means, and we have built clusters. I hope this helps you to do the clustering, and for any questions and comments, you can reach out to us. And so stay tuned. So do subscribe our channel.